We're given two different situations in this problem, a boat that goes downstream and then it goes upstream. And we're given, I'm going to highlight certain things. We're told that the speed of the boat, all we know about it is that it's 1.5 miles per hour faster downstream than upstream. And we also know that it takes 4 hours less time to go downstream than upstream, of course, because it's faster. And we also know the distance traveled, which is 36 miles. And these are all important factors when you're dealing with speed problems. So to summarize all of this information that we have here, what I'm going to do is I'm going to make a little table, and I'm going to look at what is all the information that I have about this boat going downstream and upstream. And the important factors that are given to me are the distance, the speed, and the time. Now, since the goal of this problem is to find out how fast, as in the goal is to find the speed, what I'm going to do is I'm going to say that let the speed upstream be x miles per hour. That means that the speed of the boat upstream is x, so I can fill in this column over here. Let's make some more columns to make this less confusing. And I also know that the speed of the boat downstream is 1.5 meter per hour faster, right? So the speed downstream, if the speed upstream is x, will be x plus 1.5. So I can fill in this column too, x plus 1.5. Okay, what else can I fill in? The distance is easy. I know already that it's just 36 miles, so I can fill in the distance downstream as well as upstream traveled is 36 miles. But we still need to find out the time. And all we know about the time is that we're told that it takes 4 hours less time to travel downstream. Now, I'd rather not include another variable of time, so instead, I'm going to write down a very, very important equation, and that is that the speed at any given time is always the distance over time. This is an important formula. Now, I need to find out what the time is. So if I rearrange things in this formula, I get that the time is equal to the distance over the speed, right? So this tells me that, well, technically, the time taken to go downstream should be 36 over x plus 1.5, since the time is distance over speed. And the time taken to go upstream should be 36 over x. So we filled up this entire table now, and it nicely summarizes all the information we need. Except there's one thing we didn't use. We haven't used that it takes 4 hours less time to go downstream than it goes to go upstream, the same distance. So this is what is going to give me the equation that I'm looking for. So the equation that I'm looking for is that, okay, so when it goes downstream, it takes 4 hours less time. So if I was to look at the time that it takes to go upstream, and if I was to subtract the time that the boat takes to go downstream, I should be able to get 4 hours. And we have all of this information, so the time taken to go upstream is 36 over x, and the time taken to go downstream is 36 over x plus 1.5, and that is equal to 4. Now this is great because now we have an equation that we can work with. So the rest of my energies are going to be focused on just solving this equation. First of all, I have terms in the denominator that I don't like. So step 1 is going to be to find the LCD for this equation. Since I have x and x plus 1.5 and this is 4 over 1, the LCD for this equation is x times x plus 1.5. So step 1 is going to be to multiply the LCD to all the terms. So I'm going to rewrite this equation as x times x plus 1.5 times 36 over x minus 36 over x plus 1.5 times x plus 1.5 equals 4 times x plus 1.5. Okay, let's start with cancelling all the factors that we can. So I can cancel x from this term, x plus 1.5 can cancel from this term, and this is great because now I got rid of all the denominators. Now I multiply. 36 times x is 36x, and 36 times 1.5 is 54. You may check this using your calculator. Minus 36 times just x is 36x. Now we got rid of the x plus 1.5, remember? And on the right hand side, I have 4x times x plus 1.5. So on the left hand side, I can simplify the 36x and the 36x cancel. And on the right hand side, I need to multiply this 4x inside to both of these terms. So I get 54 equals 4x times x is 4x squared, and 4x times 1.5 is plus 6x. Now this is a quadratic equation, so to solve it I have to bring all the terms to one side, so I just need to bring this 54 over, and in order to do that I'm going to subtract 54 from both the sides. And just to write the equation conventionally, I have 4x squared plus 6x minus 54 equals 0. Now I want to use the simplest version of this equation possible, so I'm going to divide both the sides by 2. Before I even start to do this, I just want to say that if you are more comfortable using the quadratic formula, you can go ahead and find the solution to this. But I'm going to solve this by grouping and factoring, because I think that I should be doing this grouping and factoring, because I think I should be doing this method at least once. Okay, so to group and factor, well, first of all, I'm going to divide the entire equation by 2. So I have 2x squared plus 3x minus 54 equals 0. Now when your x squared has a coefficient, it's really important to not neglect that. So what you need to do is you need to multiply 2 times, well, sorry, not 54. 54 is divided by 2, so the number here, each of these terms got divided by 2, so the number here should be 27. So going back, what we're going to do is we look at these two numbers and we multiply them. So 2 times negative 27 will be negative 54. So what you're looking for is you're looking for two numbers which when you multiply you get negative 54, and when you add them you get positive 3. Now you know that 6 times 9 is 54, so the numbers here should be 6 and 9, but since I have a positive 3, it's probably negative 6 times 9, because negative 6 plus 9 gives me positive 3. Okay, but in grouping and factoring you can't just write down both the factors directly. You have to do some more work than this. So I'm going to rewrite the middle term as 2x squared, and the 3x I'm going to rewrite it as minus 6x plus 9x minus 27 equals 0. Now we group and factor. So I'm going to group the first two terms together and the next two terms together. And so 2x squared and 6x, what do they have in common? They have the 2 in common and they have the x in common. So I'm going to pull those out and I get 2x. Once I pull out 2x from 2x squared, I'm left with x. And if I pull out 2x from negative 6x, I'm left with negative 3. And what's common between 9 and 27? Well, 9, and 9 times 3 is 27. So the next one, I pull out a positive 9. And when I factor out a positive 9 from 9x, I'm left with x. And if I factor out 9 from negative 27, I'm left with negative 3 equals 0. Okay, now I have x minus 3 as a common factor in both of these terms. So I'm going to factor out the x minus 3, and then I'm left with 2x plus 9 equals 0. Okay, so now by the zero product rule, I have two possibilities. I either note that x minus 3 is equal to 0 or 2x plus 9 is equal to 0. I solve both the sides. On this side I get x equals 3, and on the other side, well, if I take the 9 over, I get 2x equals negative 9, and then divide both the sides by 2, so you get x equals negative 9 over 2. Okay, but let's go back and remember what we had marked as x. X was supposed to be the speed upstream. So since we have these two possible answers, negative 9 over 2 is not acceptable because speed cannot be negative. So which means x equals 3 is the correct answer to this question. So we can write down that the speed of the boat downstream is 3 miles per hour and the speed of the boat upstream is 3 plus 1.5, since it was 1.5 miles per hour faster, which is 4.5 miles per hour. And that's the answer.